ముందుగా ప్రియమైన విద్యార్థులకు మరియు వారి తల్లిదండ్రులకు నమస్కారం. నా పేరు కె వెంకన్న జూనియర్ కాలేజ్ చైర్మన్. నేను ఈ రోజు 10th క్లాస్ విద్యార్థులను దృష్టిలో పెట్టుకొని మాట్లాడడం జరుగుతుంది. అది ఏమిటనగా, మనందరికీ తెలుసు, గత 2 సంవత్సరాలుగా కరోనా కారణంగా విద్యార్థులు ఎటువంటి పరీక్షలు రాయకుండానే పై తరగతులు పంపడం జరుగుతుంది. ఫలితంగా ఐఐటి జేఈ మరియు నీట్ లాంటి జాతీయ స్థాయి పరీక్షలను సాధించడం కష్టతరం అవుతుంది. దీనిని అధిగమించడానికి మరియు 10వ తరగతి పరీక్షలో అత్యధిక మార్కులు సాధించడానికి నేను మీ ముందుకు కె వెంకన్న జూనియర్ కాలేజ్ ప్లాట్ఫామ్ ద్వారా అనుభవజ్ఞులైన అధ్యాపకులచే ఉచిత వీడియో క్లాసులు, హ్యాండ్ రిటన్ నోట్స్ మరియు గత ప్రశ్నపత్రాల సమాధానాల విశ్లేషణ ఇవ్వబడును. కాబట్టి నేను విద్యార్థులకు చెప్పదలుచుకున్నది ఏంటంటే, ఈ ఉచిత వీడియో క్లాసులను మరియు హ్యాండ్ రిటన్ నోట్స్లను క్లాస్ రూమ్లో కూర్చొని చదువుకున్నంత సీరియస్ చదువుకోవాలను. ఇంకొకటి ఏమిటనగా, ఈ యొక్క క్లాసులు విన్న వెంటనే అర్థం చేసుకొని ప్రాక్టీస్ చేయవలను. ప్రాక్టీస్ చేయడం అంటే కేవలం చదవడం కాదు, పేపర్ మీద రాయవలను. అలాగైతే గుర్తుండిపోతుంది. దీంతో పాటు మీ యొక్క నాలెడ్జ్ని పరీక్షించుకునే కొరకు త్వరలో ప్రీ ఫైనల్ పరీక్షలు కూడా నిర్వహించబడు. ఈ యొక్క అవకాశాన్ని సద్వినియోగం చేసుకోవాలని 10th చదివే విద్యార్థులకు విజ్ఞప్తి చేస్తున్నాను.
What is the dimensions given? 7 into 15 meter and height is 8 meter. So this is given as 8 meter. This is given as 7 meter. This is given as 15 meters. So when this is 7 meter, what is this to be? 7 meter. What is this length to be? 7 by 2. Remember that. Anyway, I will write all these dimensions again. So this is a 3-dimensional figure. So it is a 3-dimensional figure surmounted like this. Let me explain this kind of figure and combination structure in our day-to-day life. I will explain this in Telugu so that you will understand it. మనం కొన్ని కళ్యాణం ఫంక్షన్ హాల్స్కి వెళ్తాం, కళ్యాణ వేదిక అంటారు. అలాంటి చోట రేకులతో తయారు చేస్తారు. ఒక స్ట్రక్చర్ తయారు చేసి ఇలా క్యూబాయిడికల్ షేప్లోనే ఉంటుంది. అది ఇలా చేస్తారు, దీనిపైన ఇలా వేసేస్తారు. ఇదంతా రేకులతో చేసి ఇక్కడ ఫాల్స్ సీలింగ్ వేస్తారు, మీరు చూసే ఉంటారు. It's a combination structure. It's almost the same kind of cuboid on the bottom and the top is a half cylinder. So ఇది డే టు డే లైఫ్లో మనం చూసే ఎగ్జాంపుల్. Let me now take the problem part of it. It's a typical question given with 3 cases in it. The first case is that what is the volume and how much air is being spread in the combination structure. Let me read out the problem. Find the volume of the air that the shed can hold. He is calling the whole thing as shed. What is the volume of the shed? So volume of shed is volume of cuboid plus volume of half cylinder. Am I right? And now let us talk about the dimensions. What is the volume of a cuboid formula? Volume of a cuboid is LBH. Am I right? Volume of the cylinder, half. When you look at the cylinder like this, it is the cylinder. So cylinder volume is pi r square h. So this is radius, this is height, this is diameter. So you can write it as diameter by 2. LBH half times what? Pi r square h. What is pi? Let it be like that only. What is r square? 7 meter by 2. 7 by 2 into 7 by 2. Have you understood this? Half pi r square. Otherwise I will write this as first formula, then substitute that. Half pi r square h. LBH. What is L? 7 into what is B? 15 into what is height? H into half times pi 22 by 7 into r square is 7 by 2 into 7 by 2 into h is the same 15. So this, after simplification, you will get some value. This is the first part of the question. But the second part, he has mentioned that further, suppose that the machinery occupies space of 300 meter cube. Machinery volume is 300 cubic meters. And there are the employees, 20 workers are working with 0.08 meter cube. 20 workers occupying some volume. Occupying volume is 20 into 0.08. Let me see the problem once again. Because it's a lengthy problem which cannot be accommodated on the board, I have not written the full problem. There are 20 workers, each of whom occupies about 0.08 cubic meter space on the average. 0.08 cubic meters on an average. This is the total volume of 20 persons. What do you mean by 20 workers occupying volume? Say for example, I am standing here on the dais in this cuboidal room. So I am occupying some volume. This podium is occupying something. So like that there are 20 students. 20 students will occupy something. So in the total volume, there are 20 workers occupying 20 into 0.8. This is the total volume. Let it be like that. For afterwards we will simplify it. So volume of machinery, he has already given. What is that? 300 cubic meters. Volume of 20 workers given. What is that? 20 workers on an average. 20 into 0.08. So you can write it as 10 into 0.08 is 2 into 10 into 0.08. This is 2 into 10 will go inside 0.8. So it is 1.6 cubic meters. Look at this. This is already given. But here, what is the volume after these two are being occupied? Remaining volume. I am not simplifying it here. Remaining volume is this particular volume. 7 into 15 into 8. 15 into 8 is 120. 120 into 7. 840 plus half into 7 goes here. 2 goes here 11 times. 15 into 7, 105 into 11, 11 into 105 by 2. This after simplification, 840 plus 11 into 105, 1155, 1155 by 4. After simplification, you can try that. That answer I am writing here, 1128.75 square meters. So, total volume is, I am writing this as V1. V1 minus V2 minus V3. This I am calling it as V2. This I am calling as V3. So after simplification, the board is not permitting me to do that. You can do it. You will get it as 827.15 cubic meters. This is the answer. So I have left the answer for you to do it. All these three are to be taken care of. I will explain this problem. It's a tricky problem, lengthy problem. Worked example in the textbook. You can look at the page number 256. The full problem is given in a word problem. If I write the whole problem, this itself takes half the page of the board, so I have not written it. So a shed is in the form of a cuboid with a surmounted figure as half the cylinder. Dimensions are given. Height is 8 meters, length is 7 meters, and breadth is 15 meters. This is the cuboid dimensions. And the no dimension is given about the half cylinder. We consider this because is half cylinder means this particular portion fits here. So the diameter should fit here as the length. Therefore, length is equal to diameter. Therefore, radius is 7 by 2, and the height, this particular length should fit here on the top. Then only you can see a shed-like structure. We talk about this kind of marriage halls. So a marriage hall with a asbestos sheet shed. So this is a figure, a cuboid surmounted with a right circular cylinder, half the right circular cylinder. It's a combination structure. So because the problem is lengthy, I have taken three parts. What is the volume of the air? For that, volume of the shed is nothing but the volume of the air. So This on simplification you get V1 cubic meters, and inside there is some machinery. What is the machinery volume? 300 cubic meters. That I am writing it as V2 because it's already given, you don't need to simplify it. What is V3? There are 20 workers working in the shed. They occupy some volume. Even if they keep moving inside, their volume is 20 into 0.08, which is already given. So the given data only I am writing directly here. So it is volume 2. After simplification is volume 3. So we want the open area, volume of the air. So it is remaining volume is total volume minus 300 minus 1.6. That after simplification is 827. So you can simplify it and calculate it at your convenience with the help of the textbook. I hope you enjoy learning these 3 problems. This problem, though it looks lengthy, understanding the problem is little difficulty, but V2 and V3 are given here. Only thing is you have to find V1. Finding V1 gives 5 marks, and these 2 data already given 1 mark each. So 5 plus 2 7 marks. Remaining volume is just subtraction. After simplification you will get the total volume. So it's a 8 mark question. If it is given for 8 marks, don't get scared by looking at the problem size, but it's a difficult problem, no doubt. But when you practice it for 1 or 2 times, it's easy. But drawing the figure, you should be very careful. After that you can get the answer. I hope you enjoy learning this volume combination structures. We'll see some more problems later.
Hello students, my name is Vishal Kumar Sharma and I did my BTech from IIT Kanpur. Right now I am associated with K. Venkana classes, and at K. Venkana classes we are bringing your IIT top Delhi faculties. I am an HOD of mathematics at K. Venkana classes. Okay. Now if you are choosing MPC, then you will have a chance to be taught under top Delhi faculties. If you are choosing BIPC as your subject, then you will have not only IIT faculties as well as a proper doctor teaching you. Similarly, we have if you are choosing MEC and CEC, so after second year for your CA-CPT exam, we have a very expert faculty specializing in CA-CPT. So what are you waiting for? Come and join KVC.
I am Yogananda here, teaching class 10 mathematics. We are dealing with mensuration chapter. We are at the end of the chapter doing combination of solids problems, word problems, important problems from the examination point of view. We will take few more problems of that kind. Let me explain one more problem. You have to understand the word problem beautifully in it, and you have to draw a geometrical solid figure and mention whatsoever is asked in the figure as far as possible. So let me try one more problem. A wooden article was made. A wooden article was made by scooping out a hemisphere from each side. A hemisphere from each side of a solid cylinder. Here cylinder means right circular cylinder. Here shown in the figure. The height of the cylinder is is 10 centimeter, and its base is 3.5 centimeter radius. Radius of base is 3.5 centimeter. Find the total surface area of the article. Find total surface area of the article. It's a article which is scooped out from a wooden solid. So understand the figure first. Cylindrical cylindrical solid. Look at the cylindrical solid. From the cylindrical solid, what is that? How the article is made? What is that article made of? How is it made of? It is made of by cutting out something from this wooden article, solid article. How is it done? It is done like this. This particular portion is being scooped out. When we say scooped out, you understand what it is. మనకు జనరల్గా when we go to marriage functions and all that, at the end of the dining section we will be served ice cream. When they serve ice cream, how will they serve the ice cream? With a scoop, a spoon like article with which they scoop out and give the ice cream and put it in a cup and serve us. Like that, it is scooped out like this. Just look at this. So when you scoop it out, if it is spooning out, it is not exactly hemisphere. When you take a scoop and do it so, hemisphere is being taken out. So a scoop is in the form of this. So you can look at this. So they scoop out this. So when they take out, scoop it out, exactly half the spherical portion is chilled out or taken out, chiseled out or taken out, whatsoever it may be. So this is the article. So our article is made of wooden cylinder, cutting out some portion from that. What kind of portion is being taken out? Half sphere is taken out from the bottom and the half sphere from the top. That is the question. Now, and the question involves total surface area. The height of the cylindrical portion is already given as 10 centimeter. So we'll take this as h. This is radius. Solution: height given. Height is h is equal to 10 centimeter. Radius, he has mentioned clearly, its radius of base is 3.5 centimeter. R is 3.5 centimeter. Now we have to find the total surface area. So we have to find out for the hemisphere. What is the radius? Or say 3.5 centimeter. So what is the curved surface area for the hemisphere? 2 pi r square. 2 times pi times r square. 3.5 into 3.5. What is pi? 22 by 7. So this is nothing but 2 into 22 by 7 into 3.5 is written as 35 by 10 into 35 by 10. 7 goes 5 times. 2 into 5 is 10 gone here. So 10, 22 into 35. 22 into 35 by 10. 2.2. So it is 350 plus 35. You multiply it this way, 22. 770 divided by 10, which is 77.0 square centimeter. So this is hemisphere. So now we are talking about the total surface area, curved surface area of cylinder. What is the dimensions for a cylinder? For cylinder, height is h 10 centimeter, radius is 3.5 centimeter. Curved surface area is 2 pi r h. 2 into 22 by 7 into radius. What is the radius here? 35 by 10 into 10. So 7 goes here 5 times. 10 goes here 5 into t to 20. 10 into 5 into 2. 10 into 22, so which is 220. So this is the curved surface area, outer surface area. Inside two areas are there. What are that? So required area is required area is total surface area plus curved surface area 1 plus curved surface area 2. What is total surface area? 220. Curved surface area is 77 plus again 77. So it is 220 plus 140, 154. So it is 354 plus 20, 374 square centimeters. This is the question. So let me explain this problem. All of you look at this. In the conic section, in the combination solid, a article is cut out from a cylindrical wooden piece. How it is done? It is scooped out on the top and scooped out in the bottom. So both the scooped out portions are taken out, and after that the inside surface area and inside curved surface area is being considered, and the outside total surface area is considered. So for that, the total surface area required is curved surface area of the cylindrical portion minus plus inside top area, inside bottom area. All that is 220 plus 77 plus 77, which gives 374 square centimeters. Now let me do one more problem which is very important. Theoretically, surface area of a sphere, surface area of a sphere and cube are equal. Find the ratio of their volumes. The question looks very easy. Find the ratio of their volumes. This is the question. Surface area of a sphere and surface area of a cube are equal. Find the ratio of their volumes. This is the question. So first of all, draw a sphere. I am drawing a simple figure like this. Small figure, because I have to accommodate the whole problem here. I am drawing a sphere. What is the radius? R. And a cube. So a cube. Side is A units. So we'll take radius is R, side is A units. Surface areas are equal. What is the surface area of a cube? 6 times A square. Am I right? Because 6 surfaces are there of square like things. Each square is A square, 6A square. What is the surface area of the sphere? 4 pi R square. Surface area 4 pi R square. Surface area here is 6 times A. Given, what is given? 4 pi R square is equal to 6A square. So now we have to convert this in terms of 4 pi R square equal to 6A square into a ratio between R and A. So this is A square is equal to 4 pi R square into 1 by 6. 2 times 3 times. So it is 2 by 3 pi times R square. So what is A? 2 by 3 pi is under root, and R square also is under root. So this is R. R times root 2 by root 3 times root pi. Look at this. A is equal to R times root 2 pi by root 3. That way also you can write. We got A is equal to